This is Honors Algebra 2 Pre-Calc. We're doing 10.4 in Pre-Calculus, which is hyperbolae. In example 2, we're asked to graph the hyperbola, give the coordinates for the vertices, the center, and the foci. So again, when we talk about this, the first thing we have to do is we have to identify the center. So remember that it's easy to accidentally get these in the wrong order, but x is always the h, like x minus h. So in this situation, this is x minus h, which would be the x coordinate of the center rather. So I get that h is 2, and then this is y minus k. So k must be a -1. So the first piece of information I can get, we'll give myself a little bit of space, is that the center should be at 2, -1, right? The second piece of information that I need to get from this is that because the y squared is the positive one, a squared, right? A squared is 4, meaning a is 2 in the y direction, right? Because it's under y. So again, in hyperbola, it's not which of the denominators is larger. In an ellipse, the larger number is a. But in a hyperbola, the one that has the positive fraction is a. And my b squared would be 9, which means b is 3 in the x direction, right? So that's going to help me draw this box that I need to draw. So I'm going to draw some stuff, and then I'm going to actually answer the questions about the coordinates after, because it's a lot easier. If you have to graph anyway, it's kind of easier to graph stuff. So let's put the graph over here, okay? So my center is at 2, -1, and I'm going to need to be able to move up and down 2 units and left and right 3 units. So you should make sure you give yourself enough room on the graph to do that. So I'm going to graph down here, right? So oh, that's not a very good horizontal line, which is only pronounced by the fact that I'm drawing on a whiteboard calendar which has lines, and I totally missed. Okay, so 1, 2, 3, 4, 5. Make 5's bigger because it's easier. 6. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, cool. So 2, -1 is my center, right? From that center, I'm now going to follow directions. I'm going to go A in the y direction. Well, A is 2, so in the y direction, I'm going to go 1, 2, and I'm going to put a vertex, right? Because the vertices are at the ends of the A, right? And I'm going to go 1, 2 up, and that's going to be my other vertex, and I label them with V. In the x direction, I'm going to go B units, which is 1, 2, 3 in this problem. 1, 2, 3, right? And then I'm going to make this like invisible box, right? Just horizontal and vertical lines that hit all 4 of those spots. It's my invisible box. And then the reason I make that box is I use that invisible box to make the asymptotes. So these diagonals are actually why I'm making this box. I make the box specifically for the diagonals, but it's hard to draw them correctly without the stupid box. Okay, once I have those diagonals, I'm then going to start at the vertex, right? And I'm going to just trace along these crazy asymptotes, right? So that's branch 1, and it doesn't have to be perfect, and you can go back over it if it's not great. And then branch 2 is going to start at the other vertex and go along the asymptotes, right? So that's my graph. So once I know that, it's a little bit easier to go back and talk about the vertices, right? So my vertex is 2 units above the center or 2 units below the center. Well, what that means is if we can probably squeeze this stuff. We'll go over here. All right, so the vertices, right, the vertices are going to be 2 units above this 2, -1, which would be 2, 1, and also 2 units below that, which would be 2, -3, right? Essentially what I did is because it was y motion, I just did plus or minus 2. I did -1 plus or minus 2. -1 plus 2 gave me a 1. -1 minus 2 gave me a -3. So that's my vertices. Now the foci, in order to find the foci, I'm going to have to do a little bit of math, right? So in a hyperbola, a squared plus b squared equals c squared. Well, we know a is 2, so a squared is 4 plus b squared is 9 equals c squared. So I basically get that c is the square root of 13. So the easiest way to write the coordinates of the foci, right? You can be a lazy bum. You can just say, hey, I get that the foci go in the same y direction, so my foci should be 2, -1 plus or minus a root 13, and that would be a totally okay way to write that answer. The other way to write it would be to write it as 2 coordinates, 2, -1 plus root 13, and 2, -1 minus root 13, and that would be totally fine. Now, if you were trying to plot the foci in your graph, you'd have to think about what root 13 is approximately. Just as a quick note, it is really important to be able to approximate values. So to know that root 13 has to be bigger than root 9 but smaller than root 16 matters, right? So root 13 has to be bigger than a 3, because that's what root 9 would be, and smaller than a 4, because that's what root 16 would be. So like this is 4.5-ish. sorry, 3.5-ish. Come on, brain. Come on, brain. You had one job. So it's 3.5-ish. Doesn't mean it's actually 3.5. The 13 is slightly closer to the 16, so it's actually probably higher than that. But it doesn't really matter, because if you're plotting those points on a graph, you would never write 3.5 over here. That would be wrong. You should keep it as root 13. But for your visual purposes, if you're trying to plot points on a graph, you can say, hey, it's 3.5-ish. You're not expected to be more accurate than that. So 1, 2, 3.5-ish. There's my focus, right? 1, 2, 3, 3.5-ish. There's my focus, right? And you can see it's not surprising that the parabolae, or rather the hyperbola branches, which kind of look like individual parabolas even though they're not, the hyperbola branch bends around the focus, right? Because you pay attention to the focus of something. When you're asked to focus, you look towards it and pay attention. So that's kind of the gist. That's our example 2.